Dear students, welcome to virtual classroom of Municipal Corporation of Greater Mumbai. I am Sreekumar. The class is for 10th standard students. Subject is mathematics. Let me begin the class. Dear students, we are entering into a new chapter. The chapter is trigonometry. The name is not new for you. You have learned about trigonometry and trigonometric ratios in class 9, and this year you will be learning more about it. Of course, you have to remember and recollect the trigonometric ratios that you studied in class 9. Here you will be learning more about it, especially some trigonometric identities along with more ratios, and as well as you will be studying about the concept of angle of elevation and angle of depression, as well as problem related to heights and distances, which is having close connection with what we say trigonometry and its ratios. So my first attempt will be to make you recall or remember what you studied in class 9. Okay, you should recollect that perfectly. You can go to the 9th standard textbook also. You can also try to remember all those symbol ratios you studied regarding trigonometry in class 9. I will be pasting the link to class 9 video which I have made so that it will be useful for you to recollect and remember. Anyway, a small recall will be done now here on the screen, which will be again from your 9th standard textbook. This is the summary of what you learned in class 9 regarding trigonometric ratios. Especially, you remember that trigonometric ratio is applicable to right angled triangle, and you also know that whenever you studied about a right angled triangle, first thing that comes in your mind, it is having a 90-degree angle. Another thing comes in your mind is regarding the hypotenuse and adjacent sides. Hypotenuse is the side opposite to the 90-degree angle. And you will surely remember about Pythagoras Theorem, which connect the ratio and the relationship between what we say the sides of a right angle triangle, where hypotenuse side square is equal to the sum of the square of other two sides. This you have studied. Last year when you were studying about class 9, the similarity of a right angled triangle or similarity of triangle, which gave you the idea for comparing the sides of right angled triangle. Okay, what is there in front of you is the table taken from your 9th standard textbook regarding the ratio that you get when a right angle triangle, and apply the trigonometric ratios for 0 degree, 30 degree, 45 degree, 60 degree and 90 degree angle of the given right angle triangle. You studied about 3 important ratios: ratio sine of each angles, sine ratio of 0 degree, 30 degree, 45 and 60 and 90 degree. You learned how did we get that, and you at last started using it, and you to a greater extent learned it by heart. Learned it by heart did not happen. First you understood, then by hearted. So now you should remember it very clearly before going ahead. Otherwise, go back to 9th standard textbook or go back to 9th standard video and come back and continue. These ratios are the fundamental ratios of trigonometric ratios. Okay, let us go ahead. We are going little further in order to develop new ratios out of it. Before that, this is also from your 9th standard information or knowledge. Here is a right angled triangle which is named as PMN, and let us apply a little bit of our previous year knowledge over here. We studied about this is the angle named as theta. That means a measurement. If this is a 90 degree angle, so it is a right angle. if this is 90, the remaining two angles like angle P and angle N, angle P and N together will make 90 degrees. So if this is theta, naturally this will be 90 minus theta, because P plus N is equal to P, angle P plus angle N is equal to 90 degree. So naturally angle P will be 90 minus theta, where N is given as theta degree. So angle P plus theta degree is equal to 90 degree. So angle P will be equal to 90 minus theta. That is why it is written 90 minus theta here. Now I'm telling you the fundamental basic what you already know. Some of you will be feeling that why sir is repeating this again, but for others who are not getting the memory of 9th standard, let us think about the first concept you studied about sine theta. That means we know that sine of the angle theta, the ratio will be in such a way that opposite side upon hypotenuse. I am writing it in short. So if in this case it will be simply Pn upon Pm upon, this is opposite side of theta, and hypotenuse, for example, it will be Pn. Okay, so what is written here? This is from your textbook. Cos 90 minus theta is equal to sine theta. One particular instance I would like to explain to you. Suppose that if we are taking cos 90 minus theta, cos theta is adjacent side upon hypotenuse. So cos of actually it is cosec ratio of, we write it as cos of 90 minus theta means this is the adjacent side, this is the hypotenuse. That means adjacent side upon hypotenuse. Please remember I have taken cos of not theta, theta का नहीं लिया है, 90 minus theta का है. So adjacent side upon hypotenuse. This 90 minus theta का adjacent side, again it becomes Pn, and hypotenuse of this triangle is of course Pn. So we can write here also Pm upon Pn, here also Pm upon Pn. So we can accept this. Understood? So why I wrote this? This same way sine 90 minus theta becomes cos theta, sin theta upon cos theta, tan theta, that you learned very well last year, and as tan theta is sin theta upon cos theta, and naturally cos 90 minus theta का आंसर sin theta हो गया, sin 90 minus theta का आंसर cos theta हो गया. So tan 90 minus theta will be also the reverse of it. So here tan theta and tan 90 minus theta is equal to 1. If you want, I will show the explanation of that. Tan theta means opposite side upon adjacent side. So theta is this angle, opposite side is Pm, and adjacent side is Mn. Now tan 90 minus theta means we have to consider this angle, opposite side is tan 90 minus theta, this is 90 minus theta, opposite side is Mn and adjacent side means of 90 minus theta is nothing but Pm. Now the question is multiplying these two, tan theta into tan 90 minus theta. That means we will multiply Pm upon Mn into Mn upon Pm. So naturally we will get 1 as answer. That is what is written here. So what I am trying to say, this is again from 9th standard knowledge. We have a lot of relationship between these different ratios. So you should remember this. Cos 90 minus theta is sin theta, sin 90 minus theta is cos theta, sin theta upon cos theta is nothing but tan theta, where hypotenuse will get cancelled, and tan theta into tan 90 minus theta is equal to 1. Once understood, you can learn it by heart or keep it in your mind forever. Consider certain other relationship. Now we just found that cos 90 minus theta is sin theta, sin 90 minus theta is equal to cos theta, sin theta upon cos theta is equal to tan theta into tan 90 minus theta is equal to 1. It should be 1 here, hidden in this one. Now we are going to enter into learning some more relationships or some more naming. Last year when it was asked what is the sign of a angle. Sine of an angle is opposite upon hypotenuse, and we put the name later. राइट एंगल ट्रायंगल में ऑपोजिट साइड अपॉन हाइपोटेन्यूज वाले जो रेशियो है, व्हाट नेम वी शुड गिव? देन वी विल से द नेम इज साइन रेशियो ऑफ दैट पर्टिकुलर साइड्स with respect to the angle. So what I am trying to say, we are going to give new names now. What are they? 1 upon cos theta. If you take the inverse of that cos theta, we name it as secant theta or sec theta. And 1 upon sin theta is named as cosec theta. And 1 upon tan theta is named as cot theta. So we got 3 more ratios or 3 more names we got. Earlier we had only sine, cos, tan. Now we got sec, which is that of connected with cosec, cos theta. Then cosec, which is connected with sin theta, and cot, which is connected with tan theta. All these are, simply speaking, cos theta, sec theta and cot theta are inverse ratio of sin theta, cos theta and tan theta. तो हमको क्या मालूम होना है? हमको तो बेस ही मालूम होना है. What is it? Sin theta is equal to hypotenuse upon, opposite side upon hypotenuse. So when it comes to 1 upon sin theta, it will become inverse of it. That means what it will become? It will become hypotenuse upon opposite side, and we call that ratio 1 upon sin theta as cosec theta. So we will learn 3 more new names. Don't worry, the names are ending here. आपको और पढ़ना नहीं है. इतने में आपका रेशियो का कंसेप्ट इधर फॉर द टाइम बीइंग बंद हो जाता है. देन इट विल स्टार्ट अगेन. बट sec theta, cosec theta, cot theta, ये क्या है आपको क्लियरली मालूम होना है. एंड इन अ राइट एंगल ट्रायंगल, if this angle is theta, this is 90 minus theta. So you already know that if you are taking sin theta, it will be equal to cos 90 minus theta. If you are taking cos theta, it will be equal to sin 90 minus theta. If you take the ratio of sin theta upon cos theta, it will become tan theta, and the product of tan theta and tan 90 minus theta is equal to 1. So altogether we are summarizing the knowledge. The knowledge which you learned earlier, the knowledge you learned now. This is again just put here just to see that this is from your textbook. And all these are talking about the ratios. And ultimately, once we learned all these ratios, this one you learned in 9th standard up to here. Up to here you learned in 9th standard. And how did we get all these ratios? That also you learned in 9th standard. It should be there within your mind. Now you learned a new ratio which is named as cosec, sec and cot theta, which we know that 1 upon sin theta. That means inverse of sin theta. That means we will put the inverse of sin theta. Inverse of 0 is not applicable. But inverse of 1 upon 2 is 2. Inverse of 1 upon root 2 is root 2. Or inverse of root 3 upon 2 is 2 upon root 3. Inverse of 1 is 1 itself. So we took the inverse of cos theta and wrote over here 2 root 3 root 2 2, and inverse of tan theta we are taking as it is not defined here root 3, this one inverse of 1, inverse of root 3 1 upon root 3. So my dear students, by this time you got little more to understand and little more to by heart also. Why? Because I am quite sure that you cannot draw the table and calculate or find out when you are in the examination hall. So you will be, by practice, you will be learning it by heart. But you have no doubt about it whether cot theta is cot theta. That means you will read it now. Like suppose that you wanted to know the value of 30, so you will say cot 30 is equal to root 3. ये आपको doubt ही नहीं आएगा. By practice, by doing the sums given in the exercise, by doing extra sums, you will automatically say that okay, cot 13 over root 3 है, cot 45 is equal to 1. ये cot 45 या tan 45 या cos 0 degree और sin 90 degree और ये सब 1 ही है. You will start generalizing. ये सब मुझे मालूम है. Where all root 2 comes, where all 1 upon 2 comes, where all 1 upon root 3 comes, where all 2 upon root 3 comes, you will become expert in that. But basically you learn sin theta, cos theta, tan theta, from which we developed all these things. So my dear students, first you learn this table very thoroughly in your own way. आपका टेक्निक से पढ़ो, बहुत सारे टेक्निक इंटरनेट में और आपके गाइड में और आपके दूसरे टीचर्स से भी आपको मिलेगा, बट यू हैव टू लर्न मेथड कौन सा भी हो. Now, when we again think of after the table, we know that we learned 2-3 things now. One is about sin theta, cos theta, tan theta, and from there we came to the concept of cosec, sec, and cot now, and the relationship between 1 upon cos theta, which is equal to sec theta, which is equal to cosec of 90 minus theta. When you connect all these things, you are having a matter of 9 different ratios now. To be very honest, you are having 9 different ratios. So I just wrote it once again because you learned this first, and उसका reverse को या inverse को sec theta बोला. Sec theta इसका reverse we connected with other one when we found that it is equal to cosec 90 minus theta. So in that way all these are very connected. So sometime you will be connecting sec theta directly with cos theta. Sometime you will be connecting sec theta direct with cosec theta. So all this depends upon what kind of situation comes in front of you. And please remember that tan theta is equal to cot 90 minus theta, and cot theta is equal to tan 90 minus theta. What advice I can give you is you have to spend little time with this particular what we say chapter, and you should keep a drawing alongside while learning, putting 90 degree over here and theta over here and 90 minus theta over here before by hearting. By hearting is the most common method advised by all to you, but I would say before that you will simply see that, okay, 1 upon cos theta, that means I should know cos theta. Cos theta is adjacent upon hypotenuse. So you will write that. 1 upon cos theta, you will reverse it and you will write it as sec theta. Once you wrote sec theta, you will understand, okay, sec theta is this. Then comes cosec theta. Cosec theta is 1 upon sin theta. If it is 1 upon sin theta, cosec 90 minus theta will be 1 upon sin 90 minus theta. Or 1 upon sin 90 minus theta is opposite upon hypotenuse. So you will write that. 1 upon that means hypotenuse upon opposite side, and you will naturally get all this relationship in front of you very beautifully. So that table you will make yourself, how which all are similar. So that is why a little bit of time to be spent in order to grasp this, in order to I won't tell you simply you just learn by heart and apply. Understand, then learn by heart. Ultimately it is learning by heart. But understand, oh ये सब सच है तो मैं by heart करेंगे. I cannot by heart in such a way that if you ask me to by heart something which is written in a language which I don't know, I simply by heart it will be heavy for me. Understood the meaning, by heart it, no problem. The same way. Okay, so that you should do, my dear students. I will be going little ahead regarding this topic because whatever is shown on the screen is related to 9th standard revision, and while we have to get into the 10th standard topic where you will be learning about trigonometric identities now. Okay, as I told you, we will be learning trigonometric identities now. Identities, when I use the term, you remember about the identities that you learned in algebra, especially in maths in class 6 or 7, where you studied about algebraic identities like a plus b whole square, a minus b whole square, and such. Identities are such equations only which are having direct application whenever the necessity comes, but we study about it and fix it, or we develop identities otherwise. So we need to develop some trigonometric identities in this particular topic. So what we need for that is first a triangle which is a right angled triangle. Let me try to draw a right angled triangle here. And let this be the right angled triangle. Let me name the triangle. The triangle can be named accordingly. Let the triangle be A, B, BC, and this is the right angle, as you can see. Okay, and let me mark this as theta. Theta is a symbol, alphabet used in order to represent all these things, and let me apply one by one the trigonometric ratios you studied. The first ratio you studied was about sine of an angle, sine ratio of angle theta in this case. If I simply write directly, it is nothing but hypotenuse upon opposite side. This is the opposite side, this is the hypotenuse. So I will simply write it as BC upon AC. You have to follow me quickly. Then if I write about the next ratio which you studied, it is nothing but cos theta. You have done this in 9th standard. Cos theta is adjacent upon hypotenuse. So naturally I will write AB upon AC. You can see that AB is the adjacent side of theta and hypotenuse is same. Then you studied about the third ratio, which you are familiar with. It is nothing but tan theta, and tan theta we can say BC upon AB. It is opposite upon adjacent, and these are all small letters normally I wrote. And then comes the fourth ratio of right angled triangle, which you studied later just in this video, which is cosec theta, related to our what we say sin theta, 1 upon sin theta. So we need to write the or inverse of it. Inverse of sin theta will be writing here AC upon BC, correct? And if you think about the fifth ratio you studied, it was sec theta, yeah, secant theta, which is inverse of cos theta, where you will be writing AC upon AB. Okay, then comes cot theta, the last ratio you studied. It will be the inverse of our tan theta, which is nothing but cot theta, and it is equal to AB upon BC. You are familiar with this, and you should be. Now we are trying to create identities, so we will be following the methodology developed or used in order to develop identity. Identity आपको by heart करना है, like identities बनाया कैसे, that is what is going to happen here. We will be applying Pythagoras theorem in this triangle. You should remember Pythagoras every moment you think about a right angled triangle. According to Pythagoras theorem, if you apply in this particular triangle, what we will write, hypotenuse square is equal to sum of the other two perpendicular sides. So here we are having BC square plus, that is one side, plus AB square is equal to AC square. We applied Pythagoras theorem in the given triangle. Now if I divide the whole equation by AC square, so what will happen? So I will write BC square upon AC square plus AB square upon AC square is equal to AC square upon AC square. Suppose that if I do like this, it is just like we are having a new equation here now. BC square upon AC square can be written as BC upon AC whole square plus AB upon AC whole square plus equal to AC square upon AC square. I am writing 1 because it is cancelable. When I look into this BC upon AC, I see this actually naturally. This I can see BC upon AC, AB upon AC is here. So why can't I write it as sine theta whole square plus cos theta whole square is equal to 1. So this is a new identity we got. So what we will write here now, for the way of writing is sine square theta plus cos square theta is equal to 1. My dear students, this you have to understand, and then by heart this is one of the identity for us now. Sine square theta plus cos square theta is equal to 1. How? this way. This is our proof. Nobody will ask you proof, but you will not learn anything without proof. That is the nature of a mathematics student. Okay, so we got sine square theta plus cos square theta is equal to 1 as a new identity. Please keep this in mind. From that we will develop more and more identities, just like that is our nature. We will write sine square theta plus cos square theta, right, is equal to 1 if you divide the whole equation with sine square theta or something like that to eliminate 1. Okay, we are dividing with sine square theta, here also sine square theta, here also sine square theta. So dividing the whole with sine square theta, naturally what will happen? This will be getting cancelled. Correct? And cos square theta, sine square theta, it stands as cot square theta. This one, full time. Cot square theta, this is equal to 1. 1 plus cot square theta, we got the answer as 1 upon sine square theta. 1 upon sine square theta, just now you understood that 1 upon sine theta is nothing but sec theta. So we will write sec square theta. All these relationships would be very thorough and clear with you. So we are getting not sec square, cosec square. One upon sine theta is equal to cosec theta. So what we will write? We will write 1 plus cot square theta is equal to cosec square theta. Understood? This way we develop new identities, and which is useful to us. So we developed an identity out of sine square theta plus cos square theta is equal to 1. We can call this as a new identity here. Here 1 plus cot square theta is equal to cosec square theta. We developed two identities, and the reason for developing the identity is out of this. Sine square theta plus cos square theta is equal to 1. We divided. Suppose that if we are dividing sine square theta plus cos square theta with cos square theta, what will happen? Another relationship will be developed. If I say I will show it here only, let me rub out this to find, because it will be easy for you if I do it here. I will do, sorry. I am removing this, the second identity you learned, for the purpose of continuing from here. Suppose that if I am dividing this sine square theta with cos square theta and cos square theta with cos square theta again, then one will be 1 upon cos square theta. Then what happens? This get cancelled, and sine upon cos is nothing but tan, we know. Understood? So naturally the result would be in such a way that here, if I write in the formal format, this will become tan theta, this will become 1, and 1 upon cos is nothing but sec, so this will become sec square theta. So we developed a third one. So we developed 3 equations now. There are 3 identities. So identities further you will develop in your own way as per the situation by applying principles of algebra. So my dear students, this concept of trigonometric identities, at least 2, 3, 4 identities which I just told you, you should remember, and they are the fundamental trigonometric identities. What I showed you is the fundamental trigonometric identities. These commonly used identities otherwise. Okay, so that you should remember. Now let us think about applying the concept of trigonometry in certain real situations. That is the next thing that I should do for you. Okay, please wait. Now we will be applying the learned things, like especially trigonometric identities in a real situation, as I told you. For example, if it is given that sine theta is equal to 20 upon 29, and you are asked to find out cos theta. You are asked to find out cos theta. So you have more than one way now to do it. One way you can simply, just now you learned that sine square theta is plus cos square theta is equal to 1, you learned. So you can think about squaring this, right? That means sine square theta means 20 upon 29 whole square plus cos square theta is equal to 1. So we naturally, you can square this if you want. Otherwise you can simply say that cos square theta is equal to 1 minus 20 square upon 29 square. This is the answer. When you do that, what you will get? 1 minus 400 upon 841, 29 square. This is what? Cos square theta. Understood? 1 minus 400 upon 841. If you try to solve this, how it will happen? It will be in such a way that 1 minus 400 upon 841. So 841 will be there as LCM here, and 841 minus 400. That means it will become 441, right? 441 upon 841, which is cos square theta. That means square root of that will be cos theta. Cos theta is what is asked, correct? So cos theta will be equal to square root of 441 and 841, correct? 441 is having a square root 21, and luckily this one is having a square root 29. So you got the answer. So we applied the newly developed identity here. Otherwise you can do in simply sine theta is equal to 20 upon 29 is given, correct? This is sine theta. From that we get an idea. If there is a triangle, right angled triangle, we named as ABC. ABC hypotenuse should be hypotenuse is 29. It will be a multiple of 29, and opposite side, this is 90 degree, so consider this as theta. So this is opposite AB. Let us write it as 20x. It will be a multiple of 20. That is a ratio का concept ही वही है. So in that case we can write AB is something 20x and AC is something 29x, correct? And हमको पूछा है, we don't know about the BC, so let BC, we don't know what is BC, let it be something. Okay, so we will apply the Pythagoras theorem. When we apply Pythagoras theorem in the above situation, we will write AB square plus BC square is equal to AC square. AB square is nothing but 20x whole square, and BC square is nothing, we don't know, we have written it as k square. Okay, then we are having 29x whole square. Correct, we got it like this. Now we need to find out k square. 29s square is having 841x square minus 20x square is nothing but 400x square. Correct. Now k is equal to root of this, k is equal to, this one will be equal to 841 का root 29 x square का root x minus this is equal to 20x. Correct. So naturally we get to a situation which is equal to 21x. K is equal to 21x. K is considered as BC here. Okay, when we say cos theta, what we write? Cos theta is adjacent upon hypotenuse. So we need adjacent upon hypotenuse. K is the side adjacent. We got it as 21x, and cos theta is nothing but BC upon AC, and we got it in terms of x. Let it be, we have written it in terms of x, here also x. So here we got it as 21x. So we will write it as 21x upon and upon 29x, which is nothing but 21 upon 29. वही तुमको इधर भी मिला था, वही तुमको इधर भी मिल गया. So this way also you can do that, where we have not applied much of trigonometry, but we applied this much trigonometry. The given question is having trigonometry that we applied. Otherwise this is Pythagoras theorem. So my dear students, there is no such rule that you should apply trigonometry only to solve the problem. We understood it is from trigonometric identities or the chapter, we will apply that surely, because these steps are comparatively easy. So this is a live situation where you are applying the concept of trigonometry in order to solve the situation. Okay, now suppose if I am taking another example for you to make you little more confident. What example I will? This was simply a substitution of that into the identities. You may have different situation in different questions that you will be coming across in your textbook, and you will face the situation. Facing the situation is a real learning experience. Correct. टीचर सॉल्व करके दिया, नेट में सॉल्व करके दिया, वीडियो में सॉल्व करके दिया, आप तो रियल सिचुएशन फेस नहीं करते. आपका यू विल नॉट अप्लाई योर कॉमन सेंस. दैट इज वेरी वेरी इंपॉर्टेंट. I will say one more example. If sec theta is equal to 25 upon 7, find the value of tan theta. An example. Now as soon as you see the tan theta over here, you may think about, okay, tan theta is equal to opposite side upon adjacent side, and you have a concept of sec theta also. Sec theta is nothing but 1 upon cos theta. All this comes into your mind quickly. That is what is expected from you. But you will substitute each and every one. 1 upon cos theta लिख के solve करेंगे, tan theta का substitution में solve करेंगे. Lot of things comes in your mind. And once if you practice, you will surely know this should be from identities, and in identities we have identities like sin square theta plus cos square theta is equal to 1. Next identity is 1 plus tan square theta is equal to sec square theta. अरे वाह, वही तो है, इधर sec और tan है, तो आप लिखेंगे उसमें ज़रा ट्राई करते हैं. 1 plus tan square theta is equal to sec square theta. This is an identity which we have studied. अभी हमको हमारे सामने क्या दिया है? tan square theta, tan theta फाइंड आउट करने को बोला है sec theta देने के बाद. हो तो फिर सब्सटीट्यूशन में काम हो जाएगा. we will substitute that 1 plus tan square theta is equal to what is given here, 25 upon 7 whole square. Correct. बाकी तो मिल जाएगा. Someone else may think ये sec theta tan theta देखे तो याद आएगा ये तो trigonometry का ही है, और तो वो ये काम करेंगे. बट एट द सेम टाइम सर तो बोल रहा था ट्रिग्नोमेट्री में आएगा तो ट्रिग्नोमेट्री काम करना ऐसा कुछ नहीं है. You can apply your this one what is called Pythagoras theorem also, but उसमें कनेक्ट करना पड़ेगा. तो एक राइट एंगल ट्रायंगल ड्रॉ करेंगे एंड उसको नाम दे देंगे पी क्यू आर और समथिंग एंड सब्सटीट्यूट करेंगे. क्या वैल्यू दिया है? सीक थीटा दिया है. सीक थीटा इज 1 अपॉन cos theta. Cos theta means adjacent side upon hypotenuse. This is 1 upon cos theta, reverse of cos theta. Reverse of cos theta में न्यूमरेटर में हाइपोटेन्यूस आया है तो मुझे 25 के इधर लिखना पड़ेगा. इसे मल्टीपल ऑफ 25 तो एडजेसेंट तो ये हो जाएगा 7 के कंसिडरिंग दिस एज थीटा. इतना में सब्सटीट्यूट करेगा वो में ट्रिग्नोमेट्री यूज करेंगे. फिर क्या करेंगे? पाइथागोरस थ्योरम अप्लाई करेंगे. तो क्या ये मिल जाएगा? इन टर्म्स ऑफ के मिलेगा. इन टर्म्स को के मिलने के बाद देयर विल बी कैंसलेशन एंड यू विल गेट द आंसर. सो देयर आर टू वेज टू डू इट लाइक द प्रीवियस वन. Okay, my dear students, I don't want to make you weak by helping you more. You may say that that's by my teacher's bad nature that sir is not giving the answer. Answer is there in the guide, answer is there in the internet, answer is there with your other teachers, answer is there with me also. But देखो ना, thinking process is the learning process. Understood? I am talking about the way of thinking is very important for solving a problem. Otherwise, you have no solution. If 5 sin theta minus 12 cos theta is equal to 0, find the value of sec theta and cosec theta. ऐसा भी क्वेश्चन आएगा. दिया है साइन थीटा, कॉस थीटा, सेक थीटा और कोसेक थीटा पूछा है. सेक थीटा और कोसेक थीटा पूछे तो हमको साइन थीटा और कॉस थीटा है तो उधर पहुंच सकते हैं. बट साइन थीटा और कॉस थीटा डायरेक्टली नहीं दिया. इट इज इक्वल टू 0. सम रिलेशनशिप इज गिवन. कैसे दिया है? साइन थीटा अपॉन कॉस थीटा अगर मैं लिखेगा तो क्या होगा? 5 sin theta minus 12 cos theta is equal to 0. Correct? That means sin theta is equal to 5 sin theta is equal to 12 cos theta. ऐसा हो गया ना? This is equal to 5 sin theta is equal to 12 cos theta, because I will bring this minus to the right side and will write it. If I write like this, I can write 5 sin theta upon 12 cos theta. Right? 5 sin theta and 12 cos theta. Right? Which if I put it like this, 5 sin theta upon 12 cos theta. If I bring like this, it is equal to 1 here. Sorry. Or simply I can say that sin theta upon cos theta is equal to 12 upon 5. 5 देखो हो गया ना? 12 5 sin theta 12 cos theta are equal. Here only you can simply send 5 over here on the right side and bring cos over the left side. In cross कर देंगे. So we got sin theta upon cos theta is equal to 12 upon 5. ये देखने में हमको क्या याद आएगा? tan theta. This is what I said. रेडीमेड अपना माइंड ऐसा काम करना है. tan theta मिल गया. tan theta मिल गया तो we have other way to find out. We have an identity. What is that? 1 plus tan square theta is equal to sec square theta. याद है? आइडेंटिटी बाहर होना है. तो ये tan square theta में ये सब्सटीट्यूट करेंगे, आपको आंसर मिलेगा sec square theta का. जब sec square का थीटा का आंसर करेंगे, उसका रूट निकालेंगे, आपको आंसर मिल जाएंगे. Dear student, this is an example in your textbook. Don't look there now. आप खुद सीक थीटा फाइंड आउट करेंगे। वंस सीक थीटा फाइंड आउट करेंगे तो आपको सीक थीटा इज नथिंग बट 1 अपॉन कॉस थीटा, तो आपको कॉस थीटा मिल जाएंगे। उसका उल्टा कॉस थीटा मिल जाएंगे। अब दूसरा आइडेंटिटी यूज करेंगे, साइन स्क्वायर थीटा प्लस कॉस स्क्वायर थीटा इज इक्वल टू 1। आपके पास क्या है? अभी आपके पास साइन स्क्वायर थीटा नहीं है, कॉस स्क्वायर थीटा है, क्योंकि आपने मिला इधर से, इसमें से मिल गया, से स्क्वायर थीटा से कॉस थीटा मिल गया। तो व्हाट इज नॉट अवेलेबल? साइन स्क्वायर थीटा अवेलेबल नहीं है, तो यू विल गेट साइन स्क्वायर थीटा एज आंसर। आपको साइन स्क्वायर थीटा मिले तो आप उसका रूट निकालेंगे। जब रूट निकालेगा आपको साइन थीटा मिल जाएंगे। साइन थीटा मिलेगा, उसको साइन थीटा मिल गया तो फिर पूछा क्या है? कोसेक पूछा है। 1 अपॉन साइन थीटा इज इक्वल टू कोसेक थीटा। तो मैंने आपको पूरा क्लू बता दिया, लेकिन क्लू बताने के बाद करना कुछ मतलब नहीं है। तो चाहिए तो भूल जाओ और करो। क्लू इज इंपॉर्टेंट ना। ये कैसा करने का क्लू मिल गया तो कौन नहीं करेंगे? क्लू ही नहीं, आइडिया ही नहीं आ रहे तो फिर कर ही नहीं सकते। सो माय डियर स्टूडेंट्स, एग्जाम्पल का ही है। आप ठीक है, थोड़ा परमिशन देता हूँ, अब थोड़ा एग्जाम्पल सब देखो, बिना देख के करो। एंड हर एग्जाम्पल में कुछ ना कुछ नया आइडिया, इसलिए वो एग्जाम्पल हो गया। वो एग्जाम्पल के आइडिया से आपके जो टेक्स्ट बुक में प्रॉब्लम नंबर 6, सेट नंबर 6.1 का सम अकेला बैठ के टाइम निकाल के आराम से बिना किधर देख के, बिना किसी को पूछ के, बार बार करके, by doing mistake and doing correction, by doing mistake again and again, you will correct it and get the answer. Get the answer is the target. And only 6 questions are given. 6th one is having some sub question to prove. And if those 6 questions, if you do yourself without any help, textbook bureau thinks that you will answer the questions in the question paper, and I too think the same. But on the other hand, अगर आप वो करने के लिए गाइड यूज किया या नेट यूज किया या कुछ भी यूज किया, then there is no guarantee that you will be able to do it in the board exam. फिर क्या कर पड़ेगा? You will practice it again and again. Extra question you will practice and you will think that वही क्वेश्चन आएगा तो मैं कर सकता है। बिल्कुल नहीं। This type of, these are sample examples, are samples, and practice का नाम ही प्रैक्टिस है। उसके बाद आपको प्रैक्टिस करना है। प्रैक्टिस करने का मतलब वो नहीं कि वही क्वेश्चन आएगा, वैसा क्वेश्चन आएगा। So that is what is the approach of textbook. Please believe that. That is why, जैसे हमेशा बोलते हैं साइकिल चलाने के टाइम, द मोमेंट जो पीछे पकड़ के आपको हेल्प कर रहा था, उन्होंने हाथ छोड़ा था, मालूम पड़ा आप बैलेंस करके जा रहा है, फिर आपको कोई रुक नहीं पाया, आप साइकिल चलाना शुरू किया। एंड उसके बाद प्रैक्टिस करना शुरू किया तो ऐसा सिचुएशन आ गया कि एक हाथ से भी साइकिल चलाते हैं, कोई बिना पकड़ के भी चलाते हैं। ऐसा मत करो। बट इतना प्रैक्टिस हो गया कि देयर इज नो इश्यू ऑफ राइडिंग ए बाइसिकल। दैट वे द मैथ्स इज। थैंक यू very much. Now click on the subscription button below to subscribe the channel, then the bell button to get the notifications of the new videos. Thank you.